Why do magnets stick together? If you ask a textbook, they'll tell you it's an invisible magnetic field. They draw little arrows pointing from a north pole to a south pole and call it a day. Wrong. That is fundamentally, reality-breakingly wrong. Here is the truth. Magnetism, as a unique, independent force, does not exist. At all. What you are actually feeling when you snap magnets together is the physical fabric of space and time warping. You are feeling length contraction. Einstein's special relativity leaking into your everyday life. You have felt this your entire life. Every time you pinned a bill to your fridge, you thought you were playing with a field. You weren't. You were playing with bent dimensions. Let me show you. Close your eyes and imagine holding two heavy neodymium magnets. Bring them close. You feel it, right? That sudden, violent snap. Or, if you flip one, that squishy, invisible wall pushing back against your fingers. People say that's just magnetic energy, but that's just a label. A label hiding a massive glitch in how we experience reality. Think about this. A standard fridge magnet can defy the gravity of the entire planet Earth. The whole mass of our world is pulling down on that piece of metal, and yet it stays. Why is it so incredibly strong? Here's the part nobody tells you. Those magnets are made of atoms. Atoms are 99.9% empty space. So what exactly is reaching across that dead emptiness to aggressively grab the other magnet? There are no invisible hooks, no microscopic ropes. Nothing is actually touching. So how does absolute emptiness push and pull? To answer that, we can't look at the magnets. We have to look at the most boring everyday appliance in your kitchen. Walk into your kitchen. Look at that cheap plastic souvenir magnet holding up an electric bill on your fridge. It looks entirely still, right? It looks static, peaceful. Wrong. That stillness is the greatest illusion in the universe. Underneath that quiet, boring surface, there is a violent, chaotic storm of pure electricity. This is where your intuition completely fails. We are taught that electricity and magnetism are two completely different things. Electricity is what shocks you when you touch a live wire. Magnetism is what magically holds up that piece of paper. But nature does not care about our neat, comfortable little categories. Try this right now. Rub your hands together. Fast. Feel that heat? That sudden friction? Now imagine rubbing your hands so fast they blur into a solid, burning ring of fire. That is exactly what is happening inside that cheap piece of fridge plastic. Every single atom inside that magnet has electrons. And those electrons are not just sitting there, they are spinning. They are moving wildly. But wait, that shouldn't be mathematically possible to create such a massive force. One single electron moving is a tiny, pathetic electrical current. It's practically nothing. You could not power a gnat's heartbeat with it. But inside a permanent magnet, quadrillions of these tiny negative charges are perfectly aligned. They are sweeping in the exact same direction. It is a perpetual microscopic hurricane of electric charge. People say, okay, so moving electricity makes a magnet. Stop. Think about what that actually means. Why does an electrical charge, just because it decides to move, suddenly gain the superpower to grab a completely different piece of metal from across an empty gap? There is no physical wire connecting the fridge to the magnet. There is no bridge. If I throw a baseball, it only does damage when it hits the glass. It does not break the window while it is still 10 feet away in the air. But that moving electron? It is breaking the glass from 10 feet away. It is reaching across the dark void. That sounds impossible. Until you see the trick. The trick is not happening inside the magnet. The trick is happening to the empty space between the magnet and the fridge. To understand how pure emptiness can physically squeeze a solid object, we have to shrink down. We have to zoom in, past the metal, past the atoms, right down to the chaotic dance of the electrons themselves. And we have to watch what happens when those tiny particles hit the ultimate speed limit of reality. Let's shrink down. Let's get impossibly small. Imagine you are standing inside a copper wire, but you are the size of a single proton. If an atom were a massive football stadium, you are a tiny pea sitting dead center on the 50-yard line. The electrons? They are microscopic gnats buzzing frantically in the highest bleachers. Look at this. It's hiding in plain sight. When that copper wire is just sitting on a table, nothing happens. It is electrically neutral. For every positive proton locked in the center, there is a negative electron buzzing around it. A perfect balance, a dead tie. Positive cancels negative, zero net charge. If you put a compass near this dead wire, the magnetic needle doesn't twitch. It ignores the wire completely. Now flip the switch, attach a battery. Suddenly the stadium changes. The heavy positive protons, the peas on the 50-yard line, stay perfectly frozen in place. They are locked tight in the metal grid. But the negative electrons, the gnats, they start to drift. They begin a slow, unified march down the length of the wire, a rushing river of electrical charge sliding past the frozen protons. Here is the secret they gloss over in textbooks. Even with this flowing river of electrons, the wire is still electrically neutral. We didn't add new electrons. We didn't take any away. We just made them walk. Count them up and the positive and negative charges are still exactly equal. It shouldn't push or pull on anything outside the wire, right? Wrong. Dead wrong. The exact second those electrons start drifting, a compass needle sitting inches away violently snaps to attention. The dead neutral wire is suddenly acting like a powerful magnet. Why? How did neutral metal suddenly gain the power to reach across empty space and physically twist a solid iron needle? People say, well, moving charge creates a magnetic field. Stop. That is not an answer. That is just giving the mystery a name so we don't feel stupid in physics class. How does the compass know the electrons are moving? The compass is completely outside the wire. It is surrounded by dead, empty space. There is no wind blowing, no physical gear turning. To answer this, we have to look at the literal fabric of space itself. We have to look at the ultimate speed limit of reality. Hold on to that thought because it's about to get weird. Let me tell you a secret about the universe. It has a speed limit. You know it as the speed of light, but that is a terrible name. Light just happens to be the most famous thing that travels at this speed. The real name for this cosmic boundary? The speed of causality, the speed of reality itself. Think of someone you know. Imagine they drop a heavy bowling ball into a perfectly still pond. Splash! Water ripples outward. Do the lily pads at the edge of the pond instantly jiggle? No. They have to wait for the ripple. They have to wait for the physical wave to travel across the water and physically push them. This is the exact moment physics stops making sense. If the sun suddenly vanished right now, Earth wouldn't instantly fly off into the freezing dark. We would keep orbiting a ghost star for 8 whole minutes, because gravity, just like light, takes time to ripple across the cosmic pond. Nothing is instant. Nothing. Every push, every pull, every jiggle and twist in the universe takes time to travel from point A to point B. And the absolute fastest anything can ripple across empty space is 300,000 kilometers per second. But wait, that shouldn't be mathematically possible. If the universe has a hard speed limit, it creates a massive problem for moving objects. Space and time have to physically warp, bend, and stretch to make sure no one ever breaks that limit. You have probably heard of Einstein's special relativity. People say it only matters for rocket ships traveling near the speed of light. Wrong. Relativity is happening everywhere, all the time. It is happening in your hands right now. Let me say that again, because it should break your brain. Those electrons drifting in the copper wire, they are moving painfully slow, slower than a crawling snail, just a few millimeters per second. But they are moving. And in our universe, if you move, even a tiny bit, space and time must distort around you. It is the unavoidable tax of motion. So, what happens to empty space when quadrillions of negatively charged electrons start a slow, unified march? What happens when relativity violently collides with pure electricity? The universe gets squeezed. Literally. And this invisible relativistic squeeze? We call it a magnetic field. Let me show you how Einstein builds a magnet. Close your eyes and imagine a ruler, a standard 12-inch wooden ruler. Now, throw that ruler as hard as you can. What happens? If you ask Isaac Newton, nothing. It flies through the air, exactly 12 inches long, until it hits the ground. Wrong. Einstein said no. He proved that the faster an object moves, the shorter it gets in the direction it's traveling. If you throw that ruler fast enough, it literally shrinks. The space between the atoms compresses. It becomes 10 inches long, then 8. This is where your intuition completely fails. You think the ruler just looks shorter. But it is not an optical illusion. The ruler has physically, literally contracted in space. The physical dimension has been squeezed down. This is called length contraction. The faster you go, the more space squeezes you. Now watch what this implies for the entire universe. We are back inside our copper wire. It is sitting dead on a table. Remember our stadium? The heavy positive protons are frozen. The negative electrons are buzzing around them in perfect balance. No current is flowing. The wire is completely neutral. Now imagine an electron floating just outside the wire, not part of it, just hanging out, completely motionless in empty space. Will it be pushed or pulled by the wire? No, because for every positive proton inside the metal, there is a negative electron perfectly balancing it out. The outside electron feels nothing. It feels a net electrical force of absolute zero. Now, let's turn on the battery. Let's make the electrons in the wire move. The negative gnats start marching down the wire very slowly, a few millimeters per second. Remember the flying ruler? The marching electrons are moving objects, and moving objects shrink. Even at a tiny fraction of the speed of light, relativity is merciless. The space between every moving electron in that wire compresses. The physical distance between the negative charges physically shrinks. Here's the part nobody tells you. The negative charge inside the wire is now packed slightly tighter together than it was a second ago. The physical density of the moving negative charge has increased. But wait, the positive protons are still frozen in place. They are not moving. They are not squished by relativity. The perfect balance is gone. The wire is no longer neutral. It has tipped the cosmic scales. We have just created a phantom force. Look at this. It's hiding in plain sight. Inside our copper wire, the flowing electrons have physically squeezed closer together because of special relativity. The negative charge is now denser, but the positive protons? They are completely stationary. Their spacing hasn't changed by a single micrometer. Think about this. We just packed more negative charge into the exact same amount of physical space. What happens to the poor, lonely electron floating dead still outside the wire? A second ago, it felt nothing. The wire was perfectly balanced. But now the wire looks physically different. It looks overwhelmingly negative. It is a phantom charge. We didn't add any extra electrons to the metal. We just squeezed the ones that were already there by making them move. And because negative repels negative, our lonely outside electron is violently shoved away. Boom! That sudden invisible shove across empty space, that is what you call a magnetic field. Right? Wrong. Dead wrong. That is not a unique, mystical magnetic force. That is literally just the normal, everyday electric force of repulsion, amplified by the literal warping of space and time. You are watching Einstein's math physically shove an object. But wait, that shouldn't be mathematically possible to feel this in everyday life. People say electrons only move a few millimeters a second in a wire. The relativistic length contraction would be incredibly, impossibly tiny. Exactly. If you had a ruler moving that slow, it would only shrink by a fraction of the width of a single atom. You would never notice it. So why does a magnet work so powerfully? Why can it hold a heavy block of iron to your ceiling? This is where your intuition fails. You are forgetting the scale. You are forgetting just how many electrons we are dealing with. Inside one tiny section of a copper wire, there are over 100 quintillion free electrons. 100 billion. Every single one of them is being squeezed. The individual squeeze is practically zero, but multiply practically zero by 100 quintillion. Suddenly, that microscopic warp in space-time adds up into a massive macroscopic electric shove. A shove so powerful it can pull a solid block of steel. That sounds impossible until you see the trick. We have only looked at this from the perspective of an electron standing still. Now let's watch what happens when that outside electron decides to move. Let's watch the universe bend. This is the exact moment physics stops making sense. Our copper wire is full of slowly marching electrons. We just proved that an electron standing dead still outside the wire feels a massive push, a phantom charge caused by the relativistic squishing of the moving negative particles, right? Wrong. Let me say that again, because it should break your brain. We made an assumption. We assumed the outside electron was just sitting there, completely motionless. What happens if that outside electron is also moving? What if it is drifting right alongside the marching electrons inside the wire, moving at the exact same slow speed, parallel to the metal? Now watch what this implies for the entire universe. From the perspective of that moving outside electron, look at the wire. Are the negative electrons inside the metal moving? No. If you are driving a car at 60 miles an hour, and your friend is driving next to you at 60 miles an hour, they look like they are sitting perfectly still. The negative electrons in the wire appear stationary to the outside electron. So, no relativistic squishing, no length contraction. Exactly. The negative charge is perfectly spaced out again. But wait, that shouldn't be mathematically possible. If the negative charge isn't squished, the wire should be perfectly neutral again. The positive protons are still there. Positive cancels negative. Zero net charge. Our outside electron shouldn't feel a single thing, right? Stop. Think about what that actually means. If it doesn't feel a push, we just broke the universe. We already established that the wire exerts a massive force. We saw it physically shove a needle. We felt it snap a magnet to a fridge. You can't have a massive physical shove in one scenario and absolutely zero force just because you looked at it from a moving car. The universe cannot allow contradictions. Reality must be consistent. So how does nature fix this impossible glitch? Look closely at the wire from our moving outside electron's perspective. The negative electrons are sitting still. But what about the massive, heavy positive protons locked in the metal? From our moving perspective, the wire is zooming backwards. The protons are now the ones moving, and moving objects shrink. The positive protons in the wire just got violently squeezed by special relativity. The wire is no longer neutral. It is now overwhelmingly, massively positive. And because positive attracts negative, our outside electron is violently pulled into the wire. Boom! That sudden invisible pull across empty space, that is what you call a magnetic field. It is the exact same electrical force, just flipped by relativity. Let's take a deep breath. So far, we've learned that a copper wire full of flowing electrons creates a massive, invisible electrical push. A push that only exists because the physical space between quadrillions of moving negative charges is microscopically crushed by the unbreakable speed limit of the universe. And if you look at it from a different speed, from the perspective of a moving outside electron, the negative charges stop moving, the positive protons start moving backwards, and space is crushed in a completely different way. The push becomes a pull. But wait, that shouldn't be mathematically possible to have two totally opposite physical realities. One observer sees an overwhelming negative push. The other observer sees an overwhelming positive pull. Both are real. Both physically exist. Both exert massive force across empty space. This is where your intuition completely fails. You think there has to be a single true reality, a single answer. Wrong. The universe doesn't care about your single answer. It only cares about the math. Here's the part nobody tells you. When you stick a heavy iron magnet to your fridge, you are holding physical proof that reality is relative. You are holding a block of metal where quadrillions of spinning electrons are constantly, violently shifting their perspective of space and time. You are holding Einstein's nightmare. And it gets bigger than a fridge magnet. Now watch what this implies for the entire universe. Look up at the night sky. The Earth has a massive magnetic field that protects us from lethal solar radiation. Without it, our atmosphere would boil away, and everything on this planet would die. But what is that field, really? Deep inside the Earth's core, an ocean of liquid iron is constantly swirling. Trillions upon trillions of tons of moving metal, moving electrical charges. Our entire planet is a giant relativistic machine. The Earth's magnetic field isn't some invisible magic shield. It is the literal physical warping of spacetime, created by the slow, grinding motion of an ocean of molten iron electrons. It is the exact same microscopic squeeze happening in a copper wire, just scaled up to the size of a planet. And when the sun spits 1 billion tons of deadly electrically charged plasma at us, those solar particles hit our warped spacetime and they are shoved away, not by a magnetic force, by the everyday simple electrical force of repulsion magnified by length contraction. We are alive because the universe forces moving objects to shrink. Hold on to that thought because it's about to get weird. This is the exact moment physics stops making sense. Think about what we just proved. A magnetic field is literally just an electric field viewed from a different perspective, right? Let me say that again because it should break your brain. There is no such thing as a magnetic force. There is only an electrical force. And depending on how fast you are moving, relativity warps space and time to make that electrical force look and act like a magnet. It is a grand illusion. This is where your intuition completely fails. You think electricity and magnetism are two completely different things. You think they are separate forces of nature. Stop. Think about what that actually means. If they are the exact same force, just dressed up in different relativistic outfits, then they are permanently linked. You cannot have one without the other. People say, oh, James Clerk Maxwell proved they were the same thing. Wrong. Dead wrong. Maxwell proved they were connected. He wrote the famous equations showing how moving electricity creates a magnetic field. But he didn't know why. He didn't know about relativity. He didn't know about the universe's speed limit. Here's the part nobody tells you. Einstein was the one who pulled back the curtain. He showed that Maxwell's magnetic fields were just the unavoidable physical consequence of space contracting around moving electric charges. A magnetic field is just an electric field moving at the speed of reality. That sounds impossible until you see the trick. It means every single magnet in the universe is just a frozen snapshot of relativity in action. When you hold a permanent magnet, you are holding a piece of metal where quadrillions of electrons are eternally trapped in a microscopic chaotic dance. And because they are moving, space is eternally warped around them. You aren't holding an invisible force. You are holding a tiny piece of bent space-time. But wait, that shouldn't be mathematically possible to feel this in your everyday life. You think relativity is only for rocket ships and black holes. You think it's too subtle to notice. But a simple fridge magnet proves you wrong. Now watch what this implies for the entire universe. Let me say that again because it should break your brain. Every time you pick up a simple fridge magnet, you are holding physical, undeniable proof that the universe warps space and time just to keep its speed limit intact. You are feeling the phantom force of length contraction, the violent squeeze of quintillions of moving electrons. People say magnetism is a fundamental force of nature. Wrong. Dead wrong. It is a consequence, a byproduct, a shadow cast by moving electricity in a universe where the speed of light is absolute. Think about this. Think about what that actually means. It means the everyday world you walk through is a lie. The solid ground under your feet, it's mostly empty space held together by phantom forces. The magnetic field protecting our planet, it's a relativistic mirage created by a swirling ocean of liquid iron. Look around you, at your computer, your phone, the lights in your room. All of it runs on electromagnetism. All of it depends on a universe constantly bending, stretching, and squishing the fabric of reality, just so electrons can move from point A to point B without breaking the cosmic speed limit. This is where your intuition completely fails. You thought the universe was simple. You thought magnets just stuck together because they were magnetic. But nothing is simple. Everything is connected by a deep, invisible set of rules that most people will never see. And that's the beauty of it. It's not just a magnet sticking to a fridge. It's a tiny window into the profound, mind-bending machinery of relativity. So the next time you pin a bill to your refrigerator, don't just see a piece of plastic. Feel the warp. Feel the invisible squeeze of space and time holding that paper up against the gravity of an entire planet. Leave you something to imagine. What other impossible illusions are hiding in plain sight, just waiting for you to change your perspective? If this broke your reality even a little bit, hit that subscribe button. We've got a lot more universe to break. I'll see you in the next one.